Okay, we have quite a large group already in session, so I'm going to begin. Good morning and welcome, everyone. I'm Zanae Dames, the Marketing and Events Manager at Digital, and I'm pleased to welcome you to our October webinar, Quantum Meets AI, Strategic IP and Data Governance in a Disruptive Era. As myself and much of the digital team are based in Vancouver, British Columbia, we respectfully acknowledge that we work, learn, and live on the traditional ancestral territory of the Musqueam, Squamish, and Tsleil-Waututh peoples. Please note that this webinar is being recorded and will be shared with our audiences in the coming week. If at any point during the session you have a question, please type it into the chat and we'll address them at the end during the Q&A portion. That's it from me, and I'll be handing it over to Jen, our Director of Intellectual Property and Partnerships, to get this webinar started. Thanks, Jen.
Thanks so much, Sine. Bonjour, everyone, and welcome. It's wonderful having attendees from across the country and continents. Good evening to our friends from Europe for this month's webinar. And whether you're new or a returning participant to Digital's webinar series, we're thrilled that you could join us for this Thought Leadership Power Hour. Next slide. Oh, perfect. Quantum technology is advancing rapidly, putting pressure on traditional IP frameworks, especially where it overlaps with data and AI. The convergence creates both significant opportunities as well as vulnerabilities. To remain competitive, it is important to understand ethical, security, data considerations that will shape effective IP strategies and safeguard future innovation. This intersection also raises complex questions about cross-border data flows, sector-specific compliance, IP protection for quantum algorithms and hardware, emerging standards for quantum-safe data governance, and the geopolitical dynamics shaping global collaboration in quantum technology. Over these next 60 minutes, we'll explore key differences between Canadian and European approaches to IP protection and commercialization strategies, the evolution of licensing strategies and emerging standards for quantum-safe governance, practical examples of successful quantum AI integrations and Canada-EU collaborations for quantum innovation, and a Q&A portion to close out. Next slide, please. At the heart of Canada's global innovation clusters is collaborative innovation, fueling the creation of scalable technologies with global reach. Digital's IP and data strategy turns ambition into action, helping Canadian companies build, own, and retain high-value IP that drives inclusive growth. Today's Thought Leaders session is one of the many ways we're raising IP literacy and strengthening portfolios by empowering Canadian innovators to generate, protect, and strategically deploy their IP. I have the pleasure of introducing today's guests. Please join me in welcoming Marion Forêt, Paul Gagnon, and Julien Lacheret. Marion is partner and European patent attorney at BCF Global, where she advises a wide range of businesses, including deep tech companies, on protecting and leveraging innovations at the intersection of quantum technologies, AI, and data. With over 20 years of experience, she has deep insights into the Canada-Europe perspective, is a physicist by training, holding a PhD in lasers and condensed matter. She works across fields from mechanics and electronics to quantum computing, and represents clients before the European Patent Office. Paul is no stranger to some of you who have joined us over the course of the webinar series, is partner and technology and artificial intelligence co-lead at BCF, bringing cutting-edge, diversified experience in technology law, commercial law, and intellectual property, from open source software management to software development and data architecture issues, and draws upon a vast repertoire of experience, regularly speaking on dealing with legal issues arising from AI, data licensing, and IP. And last but not least, Julien, partner and head of the IP group at BCF, advising companies from startups to multinationals on their comprehensive IP strategies, and was instrumental in setting up BCF's IP arm in Europe, BCF Global. With over 2 decades of experience, his technology knowledge includes aerospace, fintech, communications and networking, cloud services, and core AI and applied AI technologies. He's a contributor to the Intellectual Property Institute of Canada's patent course and a frequent speaker in startup, incubators, and acceleration programs in France and Canada. We have a powerhouse panel joining us today to work through some of these considerations. And with that, I'd like to kick off today's discussion. And Julian, I'll kick it off first to you. When we think about sort of Canada and Europe and the approaches sort of respectively we're taking, what are some of the key differences that you're seeing sort of in IP protection, sort of in frontier tech when we think of things like quantum? And how do those differences impact commercialization strategies?
Hi, Jean, and nice to meet everyone and to be here. Thanks for having us today. Starting with, the general IP framework and the key differences between Canada and Europe. Starting from a Canadian standpoint and from a pure IP standpoint. The reality we're dealing with when dealing with Canadian company in particular with respect to their patent strategy is that first and foremost, the focus is not necessarily on the Canadian patent per se, which we will eventually get along the way, but more on the US patent itself. And that's the main driver of the decision of the patenting strategy. And then Canada will come once we've defined this framework with respect to the US patent asset we're trying to get. So if I may somehow rephrase the question, I would lean towards comparing US/Canada versus Europe. And starting with that approach, and starting with I see IP as a toolbox of legal rights that you need to combine together to articulate and execute upon an IP strategy. So in that toolbox, you have many tools, including patent, which is one of the preferred legal tools when it comes to commercialization of technology, in particular in frontier technology. So if we unpack patent, for example, the first main difference you need to bear in mind is that Canada and the US allows for a grace period of 12 months with respect to the novelty of your invention. Meaning is that if today I publicly disclose my technology, from today I still have a year to validly file and obtain patent protection in the US and Canada. But this is very specific to US and Canada. In most other jurisdictions, including Europe, you have what they call strict novelty, meaning that if you disclose today and you file tomorrow, you won't be able to validly obtain European patent protection. So one of the first things to bear in mind when you're a Canadian entrepreneur and for some strategic reason, you know you're going to need to pursue a patent protection both in North America and in Europe, bear in mind that you need to secure your first filing prior to any public disclosure. This is easy to say from a theoretical standpoint. This might be harder to implement when you're caught in the reality of growing a business, of dealing with a researcher who have natural incentive to publish and disclose their technology. So to me, it really comes down to a matter of governance and proper process in your organization, despite the size of the organization, and make sure you properly catch assess opportunity for patenting prior to any public disclosure. So that's one of the key difference that I think people here on the webinar should bear in mind. The second aspect has to deal with the legal framework regarding frontier technology, and this is particularly true for AI software and quantum technology to some extent, is that under patent law, you have exclusion as to what cannot be patented. So essentially, the reasoning is that we don't want to allow people to obtain a monopoly over basic tools of science and math. And this exception becomes particularly important when you're dealing with frontier technology because you're trying to get patent protection on subject matters that may be at the frontier of what is eligible for patent protection versus what should remain within the public domain. So, and for decades, there were main differences between the North American approach and the European approach with respect to what can be protected by patent. And where we stand today is that from a US and Canada standpoint, you need to be able to articulate your technology in a way, or your invention in a way, that it represents an improvement on the technology or on a computing device, for example. So you won't be able to go patenting the mathematical models that you came up or that you may have developed, but rather how you've implemented this scientific discovery for a practical improvement of an underlying hardware piece of material, for example. So this is the legal framework in North America, and you have to compare it, and then Marion may probably step in, with Europe, which has a more established way of defining what is eligible or not, and which typically hinge on what we call the technical character, the technical effect of the invention. And I don't want, Marion, if you want to step in and maybe elaborate a bit more on the notion of technical effect in Europe, and then I'll take it over.
Okay, just to go back to the beginning of the question, Europe is a big market and it's a competitive market. So when you come to Europe, you have to be sure that you have protected all your innovations. And what Julian told you about the time that you can keep your innovation and just file later, as he told you, it's not possible in Europe at all. So just be sure that you have protected all your innovations before going to Europe. That's the first side. And the other side is that you have to check when you go to Europe if you are allowed to do whatever you want to do in Europe. In particular, you have to check with your European patent attorneys, you have to check with your IP strategy. If there are no IP assets from other companies that could prevent your company from doing what you want to do, whether it's manufacturing in Europe or even commercializing in Europe. So that's important, and that's not different from Canada and US in this perspective. But it's true for all territory where you're going. You have to be sure that you are free to do what you want to do because of all the existing IP assets of many companies that are already there. The second point I wanted to address before digging into your question, Julien, is that Europe actually gives you a choice, and that's pretty uncommon. That's pretty specific because we are many countries, and I work from France. I work from Europe, and any company has a choice whether to go for a few countries, depending on the market that you are interested in, or to go to Europe as a whole. And that's true for filing patent applications, filing trademarks. You can choose a few countries or all of them because of the European Patent Office that delivers European patents. And that's true also for litigations. Roughly speaking, I won't go into details, but you can choose either to go before national jurisdictions, or you can go through the European jurisdiction. It's kind of new because it has only 2 years of existence, but you have this choice. So I would say that Europe has this flexibility for innovators that could be very useful, and it should be thought carefully what is of interest for any company, depending on your strategy, depending on the market. But it is, I guess, an uncommon point, a specificity of Europe. And to dig into the frontier tech like quantum, that's true that in Europe, usually people, innovators, they tend to protect first the hardware, the material. Let's say qubit, electronic, thermodynamics that are around the system, the cubic system. And they are reluctant to file patent applications. They are reluctant to protect let's say, the software stack. It's true that it's complicated because, as Julien explained, there's a legal framework that it's a bit complicated because you don't want to protect discovery of mathematical equations, but it's not impossible. I think about, gate-based quantum computing or error correction. It can be harder to get a patent granted in that kind of field, but it's not impossible. And it has to be, again, thought very carefully in the IP strategy. But my message here is that hardware obviously is patentable, but you can also protect your software when the patent is well thought and well designed with your IP counsel.
And this is a problem or a challenge we faced many times with entrepreneur or former scientists who started frontier technology ventures, is that they have a tendency to overlook the value of the software stack, focusing their IP strategy primarily on the hardware and missing a big chunk of the value on the software stack. Bear in mind that over 50% of patent applications filed today at the US Patent Office are for software-related technologies. So yes, software is patentable. It's a matter of understanding the legal framework to properly identify and qualify your invention. But one key takeaway from today is like don't overlook the value of your software stack and don't miss the opportunity of catching value with a patent portfolio targeting specifically that stack in the value chain. So as I think as an entrepreneur, it comes down to capturing innovation as it arises, but prior to disclosure, having the proper mechanism to assess and determine what you should keep secret, what you should eventually patent protect, or what you could eventually publicly disclose to the world, or a combination thereof, and then properly execute on that strategy depending on your budget constraints. We won't go into too much technical details, but there are ways to manage your cash flow when it comes to grooming an IP portfolio. Patents are expensive, but there are mechanisms to try to spread the cost and align them with your funding round as you scale up. So I know that was the 10 minutes of the question targeting patents. I'll be very brief, and I think we'll have other questions to properly dig into the subject. But bear in mind that in terms of differences between Canada, the US, and Europe, bear in mind that when it comes to trade secrets and data and know-how monetization, the legal framework is different in the two jurisdictions. Europe allows for specific forms of IP rights targeting data sets called sui generis database rights. That makes the licensing of database slightly more structured and easy, whereas in North America, in particular in Canada, where we do not have such thing as a Trade Secret Act, it comes down to a contractual question, hence the importance to properly articulate and craft your agreements. But we'll have Mr. Gagnon here on the call dig into the topic a little bit further. So that I'll stop here for the first question because I guess we have many others to cover in the call.
Perfect. Merci. And yeah, that kind of segues, nicely sort of, Paul, I'm going to kind of switch gears and kind of look to you, with this sort of rise of quantum algorithms, hybrid AI systems, from your lens, how are you seeing licensing strategies, evolving to accommodate the unique arrangements that quantum systems and more broadly, these cross-sector applications are bringing? And sort of in a part two of that, factors that organizations should, maybe look to consider when deciding, for example, between open source, proprietary models, sort of, and other sort of inflections that come into this dialogue. So look forward to your thoughts.
Thanks, Jen. So obviously, I think a big theme for today is that a lot of quantum technology, I mean, the developments and the hardware stack is evolving, and I think the rate of innovation is increasing, which is great. but in terms of commercialization, it's still fairly early days. So those dynamics make it really quite interesting to contemplate, like, how, should I commercialize, or how should I bring to market those technologies? And I think we can start with open sourcing, or the perceived kind of trade-off on, open source versus proprietary. And it's not really a trade-off, or at least I think today, for the audience, it's often presented kind of as this really binary decision of, like, well, will you be open source? Will you be proprietary? I think the first thing is that some measure of open source, um, it's not negating at all your IP strategy. In fact, it's reinforcing it, right? So when you're licensing under an open source license, you're not saying that it'll never be yours again. You're not saying that it's now public domain. What you're saying is that you're, as the owner of the IP, you're licensing it to others under a license that is permissive. But you can be strategic on what license you decide to use, and then there's other advantages that come with that decision. And I won't. I know the goal today is not to go into the weeds of open source, but so Jen, pull me back when I go into there. But basically, this trade-off of or perceived trade-off between open source and proprietary, I think fundamentally not quite there. You do have to be proactive and identify, what those value drivers are for your business. And, as Marion and Julien pointed out, the software stack is not to be missed, right? You can't have only a hardware play. You have to kind of understand what the IP strategy is around your hardware. And that's where it gets really interesting. What we're seeing in terms of licensing strategies is that quantum technology, quantum computing has yet to really be found in a way that's interoperable, right? In a way that people can build on top of that, in a way that's really, really, going to be one of the key success factors for adoption at scale. And so, given this need for interoperability, I think some players that will win in quantum, wherever they are on the stack, are going to be players that think about interoperability, and therefore think about open source, think about opening part of the stack so that others can come build on top of it, therefore driving adoption. So I think this is that dynamic that we've seen, in hardware, right? Red Hat, bought by IBM several years ago, built a business entirely on open source software with a value add on services. I think that there's bits and pieces, AI and open source have a long-standing love story, and I think that these dynamics from ancillary fields, or the same fields, because we'll need AI for quantum, we'll need software for quantum. I think there's a lot of existing playbooks on navigating well this interaction between, what do you do, what do you open source, how do you do it, how do you create a community, or how do you get others excited about it, how do you drive adoption. And those playbooks are really interesting, and they don't really show. I think quantum will be interesting in how it creates its own version of those playbooks. But I think there's a lot of really interesting ingredients from AI and from software more generally.
Awesome. And then, yeah, before, I know, Julian, if you want to sort of jump in as well. And I think, Paul, one thing I was going to say too, as you describe this, is it sounds a bit like, regardless of what side that you're sort of on, right, whether you are looking to license or the licensee, it's the considerations of your approach of what are you enabling or allowing, right, sort of through that strategy, sort of with the licensing and with your approach to both sort of, protect yourself, but also foster that innovation. So both sides of the coin. So how do you, kind of wrap your head around
Exactly.
that, Maya?
And before, and I'll tee it up, Julien, I think nicely for what I know you want to say. I think look at AI, right? Like, the whole way that AI is produced, trained, distributed, this whole channel, this whole value chain, no one owns the entire value chain. It would be absurd to even try. So from compute to all of that, like, data preparation layers, to all of those training pipelines, to that deployment, to then once it's deployed, all of these different things. If you're a company building and distributing AI, you have to think about where you position yourself on that stack, how you interact with others. Yes, there's going to be frenemies along the way, right? Those dynamics can be competitive at times, but it makes IP, right, very, very essential and coming confidently to those discussions and confidently to those interactions. And once you've established that, then I think this will be true for quantum. It is true for quantum already. No one's going to control the whole stack. There's no feasible way to get that. And I think Julien, with an example, I think you can show how quickly that evolves and with really good example.
Yeah, sure. And maybe I'll start by the fact that we're often called during due diligence of not only just assessing like existing IP assets, but challenge the founder on their IP strategy. And very often the question is not limited to just reviewing a deck, but it triggers a very deep discussion as to where the company fits within the value chain. What are the main value drivers, and how did they articulate an IP storytelling around this deep understanding of their own company within a supply chain or a specific landscape. And I'm setting the table for a specific example regarding a company with whom we've had the chance to work with for the last almost decade, OVH Cloud. And the point here is that it really starts with the mission of the company, the value of the company, and where they define their value driver. And OVH Cloud, for those who do not know them, they are a European cloud service provider, an alternative to the US hyperscalers. And the two pillars of their strategy lies on openness and sovereignty, and essentially offering cloud services that are not tied or subject to the Patriot Act in the US, but that also allow clients to have to keep some amount of flexibility and avoid being stuck in a very closed environment. And that notion of openness translates into interoperability. And to be able to deliver on that mission of interoperability, OVH Cloud has shaped an IP strategy that hinges on a combination of open source and proprietary technologies. And it's interesting to see how, and this is based on public information. You can go on their webpage and see their commitment to open source and on what specific aspect of their technological stack they do contribute to open source, essentially for all aspects that requires standardization, accelerated adoption, and interoperability. Most of the key pieces of their technology is released under open source license, which is sometimes also bounded and covered by patent protection. And the reason they do that is to also make sure that people stay within the legal boundaries of the open source license and try not to reappropriate a technology that was first released under an open source license. And they also, in parallel, develop their own stack, which they protect through trade secrets or patent protection, which really define their value driver. So it really comes down to your ability to articulate to visualize your mission, where you fit in the ecosystem, and then make decision as to what can go under open source versus what we should keep proprietary. And this form of hybrid strategy proved to perform extremely well in technologies such as AI and very likely quantum for the exact same reason that Paul was mentioning before, that it's not true that one company is going to win it all. We're all part of a bigger ecosystem, and it's a matter of playing smart in that ecosystem. And I'll stop here. But I encourage you to go on the OVH Cloud webpage and their pledge to open source.
Wonderful. Thank you. And thank you all, sort of setting this sort of groundwork for this. Marion, I'm going to switch gears a little bit and kind of based on what we've sort of established sort of in this foundational piece, when we look at these sort of fast moving fields, such as quantum and sensing as well, for example, how, when you're sitting sort of in that innovator seat, how can innovators balance that need for speed to market, which ultimately is a major driver, with this goal of securing long-term IP protection?
Thank you for the question. That's a complex question. From an innovator, it's totally understandable that they want to communicate as soon as possible to the investors, to the public, and they want to go to the market as soon as possible. And that's true that going to this fast line can be seen as opposite to, trying to take some time to decide what will be an IP strategy that will go over a long period of time. And also, it's true that some innovators, they can say, okay, we are going to build a portfolio on our innovations now, but my innovations, they're going to change, there are going to be evolutions, and the patent, it's here, for 20 years. So what's worth? And we can see that, okay, no problem. But actually, it's not that much of opposition as it seems to be, because first of all, as Paul and Julien have told us, it's mostly about the value of the company that you want to build. So you have to take this time to think about an IP strategy. And it's not that complex and it's not that long. We're here as IP councils to shape the best IP strategy for each of our clients. And of course, it's, as Julien told you, it's a cost center. Yes, that's true. And we are a little bit of time consuming, but we are as light as possible. And you have to see the IP strategy as an investment. Because if it's not done as soon as possible, then it's too late, actually. The innovations, they have to be protected as soon as you discover them. Otherwise, it's too late. And of course, innovations will change, but do you want your competitor to do your innovations even though you are not interested in them anymore? So the message here is the more IP assets you build, the safer you are, actually. And keep in mind also that we European and Canadian, we do not feel that many patent applications in quantum specifically, but keep in mind that in China, the Chinese and the USA, they do file massive IP portfolios when it comes to quantum. So we are all playing the same game, and we have to be aware of that. And if you want to protect your company, if you want to build your company and its value, then you have to take some time. I promise it won't be that long. And it's our work to make it as easier as possible to have your company and your IP strategy in the best way possible.
Wonderful. Thank you. Thank you for sort of framing that out. Switching gears a little bit and kind of fleshing that out, we've kind of talked on sort of the IP sort of strategy side and standards. Paul, are you sort of seeing from your seat emerging standards in and around, for example, quantum safe governance, right? Looking at sort of enabling innovation, whether that's across jurisdictions, et cetera, or do you see that as a risk sort of in slowing adoption?
So there are initiatives popping up, and whenever you're looking at these kinds of initiatives or standardization, they're there for two big reasons, right? The first is finding common ground, technologically speaking, right? So interoperability, we've touched on that. And the second one is trust. And the question's framed as saying, well, is it going to risk slowing down? Well, the real risk in slowing down is having adoption that's not building trust. And I think that that's something that there's a lot of lessons in AI around that. When I started in the field, on basically working on commercializing AI models. This was 2016, 2017. We struggled quite a bit with presenting kind of new licensing frameworks, new ways to talk about this object. But we did so kind of in the goal of being really, really transparent with prospective customers about what was happening. And if you look at AI today, you look at AI governance, right? So there's different standards that were fairly recently adopted, maybe 2 years ago rather. So there's the NIST framework, there's a new ISO norm, and there's a lot of work that went into getting those standards in play. And are they commonly adopted today? Not yet. But have they kind of grounded the conversation around what it means to safely develop and deploy AI? A lot more, right? And the same thing happened with cybersecurity, 10, 15, 20 years prior to that, where negotiations around IT or SaaS agreements were very convoluted around security standards because you go through these really, and you still to some extent do that today, but these standards and being certified against them accelerates certain conversations because it doesn't really bog them down and really in the weeds of understanding, okay, well, what do you really do? There's still some due diligence required. But my point here is that much like cybersecurity, much like AI, this kind of standardization helps facilitate commercialization, right? It sets a common reference around how things will go. And I think that's trust building. And yes, there's a lot to be said about whether those standards create a moat for larger companies that can afford these lengthy standardization processes, creates a moat for those that can participate in them because they're really, really time consuming. There's also a risk that they anchor technology that, may be controlled by others. These are all dynamics that we know from standardization, from telecoms, from other fields, but still there's a lot more to be gained in developing a common framework and getting, whatever is standardizable, whatever would be, going to safety, going to quantum cryptography. Like those are all things that are already somewhat standardized and that need to be adapted to quantum. So I don't see that as a huge, these efforts to standardize as a huge break between historically what has been adjacent to what quantum is today. But fundamentally, it is trust building. So I think that's the real driver, will be the real driver for adoption, is having this kind of trustability around how things are developed and deployed.
Okay, and I'm going to stay with you a little bit to unpack and also to just kind of share sort of as you talked around sort of frameworks and standards and sort of, give a plug. So for those that are sort of on this, you were also part of a Canadian sort of in that global thought leader group around creating the Montreal data license and, some of the considerations sort of around that. So we're going to tap into this a little bit as this increasingly is coming into the conversation as well. We hear a lot around things around federated learning and shared IP models. What roles are you seeing these, if any, sort of play, in enabling sort of, ethical and secure data collection in AI ecosystems, notably as well, but also in quantum ecosystems, sort of more emergingly?
Yeah, thanks. I mean, federated learning is for those in the audience that aren't familiar, it's a technique or one set of techniques that's part of a broader set that can be called, I guess, distributed learning or decentralized learning as well. Basically, federated learning, what it does is it aims to minimize data transfers required for AI. So that the kind of operating assumption with building AI models is that all of the data will be pooled centrally, training one model, then redeployed. So federated, as the name says, it means that ultimately you're going to minimize data sharing, if not remove it altogether, and share only, for example, gradients of a model back either centrally, which is called vertical federated learning, or amongst participants, horizontal federated learning. So basically, all of the privacy or data sharing concerns drove innovation towards this model. Is it in practice today deployed? There are examples of federated learning that work. There's massive trade-offs as to whether performance will be there. I'm actually really curious to see whether the potential of quantum technologies to enable that even more so on anyways, I don't want to speculate too much, but can model weights be entangled with centralized models? I don't know, maybe. But I think there's that potential to say, well, we can challenge assumptions on, the need for centralized data. I think for quantum, it'll be interesting whether those sets of technologies can further accelerate that for AI. In terms of ethical and secure collaboration, it's always going to be a concern, and I think that that's like where quantum technologies have, I think, a technological but almost more a PR challenge of making kind of the object of quantum more knowable and more less esoteric to the common kind of user, right? So, you know, because those safety considerations, those data sharing considerations will be really, really prevalent as they are in AI. And so much like in the field of AI, stuff like federated learning was developed to kind of assuage certain concerns around data sharing. I think quantum will have to step up and do the same, either present techniques that are even more privacy preserving, which they can, but also kind of show that those techniques are secure as well.
For sure. Well, and I think also too, and given the gravity of what quantum is sort of, looking to secure, to preserve, to protect, et cetera, even more so, right? That piece comes into play, right? And what's at stake, in some ways, sort of literally and figuratively. Do
Exactly.
you have sort of, before we sort of switch gears, any sort of, several, examples that, maybe might come to mind sort of a successful quantum AI integrations, and how maybe some of the data governance or IP was handled. I know it's sort of still very early days,
Yeah.
but yeah.
I mean, not to name drop too much or at all actually, but you see different models, right? There's the players that are in the space that are actually making things available. They're really different, and I think that they've made choices in terms of what it means to understand the machines that they're building. And so what I mean by that is that you'll have some players that say, well, welcome to my quantum computer. Everything you do will be sent back to centralized servers in an increasingly hostile country. And others will say, well, look, here's here's my machine, and we understand that you might have concerns around privacy around what gets built, so you're going to run it in a private environment, and we're going to collaborate to share back the learning. So like you see those two different positions that go back to these data sharing concerns, and that have a different mindset around collaboration, different mindset around trust. You have some ecosystems that are being built that face the same struggle that any kind of early stage technology faces. The excitement and the rate of development is still, there's a gap to adoption and a gap to really like non-research applications. Although there's a lot of collaboration in research applications and a lot of value being unlocked there. So I think that there's still some play around what it means to collaborate and around AI. But I think we talked about it a couple times already. But that whole stack, the value chain, as Julien mentioned, like that's still to be defined on like what those layers will be. Right, it's not as predictable as one might think. So we're seeing a lot of like quantum inspired software applications, for example, that don't yet rely on quantum computing, but that definitely anticipate that that'll be the case in a few years' time. So definitely early days, but definitely a lot
Early
happening.
days, yeah. And I think, yeah, reiterating, there is no one size sort of fits all. And I think, as a lot sort of sits sort of in research, and now the translation of that, the opportunities and the pathways, really do open up in multiple ways. And so it's really kind of, to your point, really looking at where do you sit, where do you want to see yourself, and that's going to evolve as your technology evolves and as your business evolves and grows and maybe sort of changes. So no, thanks for sharing that. Now, Marianne, I'm going to sort of switch to you a little bit, as we're kind of, speaking to, sort of some of these examples. Are you sort of seeing sort of early wins, for example, with respect to successful Canada and EU collaborations for quantum innovation and IP strategy, and any lessons that they may offer, for sort of building this resiliency, again, without sort of, disclosing, sort of sensitivities, but sort of more general sort of, best practices that can help those with us today?
Well, collaborations, they are. we can see collaborations between academic collaborations. I was just checking my mic. For instance, there is the Quantum Flagship European Initiative, where there are collaborations between Canadian and European researchers. And I think that's a success just because this kind of collaborations do exist. So that's the first type of collaborations. Then there are also collaborations between startups from Europe and startups from Canada, or startups from Europe mainly and academic lab in Canada. For instance, there's Candela and Le Mila that have a partnership. And Candela is from France, if you've never heard of them. There's also Multiverse Computing. They're from Spain. And they have a partnership with Ping 2. And also I could cite Cobly, which is also a French startup that has a partnership with Nano Academics Technologies in Canada. So this is the second kind of collaborations. And the third that I see is that some startups do establish themselves. That's true for startup from Europe that established themselves in Canada. For instance, Pascal, they have a center in Sherbrooke, and also Candela, they have subsidiaries in Montreal and Sherbrooke also. So there are a lot of collaborations and between Canada and Europe, and yay, that's great. And collaborations, that means challenges, that means stimulations, and that's wonderful. But from an IP point of view, that means also, okay, what's going to happen to the common work, to the common innovations? Who will they belong to, And that's, of course, there's no general truth about it, but it has to be, again, thought carefully before ab initio. The two partners, they're here, and they should delimit each innovations that are their own. I bring these on innovations, you bring these innovations, they're mine, they're yours. And then they are common work. And there's no, again, general truth, but it has to be a win-win situation. And the key of these collaborations from an IP strategy standpoint is the contract. And Paul here and his team, they are the best. That's their work. They do it perfectly. But it's very important because we always know it's fine until it's not. Okay. So you have to be careful from the beginning what's going to happen to the common work. And again, it's wonderful, and it's wonderful to have challenges and stimulations, but you have to be careful and to have this IP strategy. And also, a second point I wanted to address is that when there are collaborations between Canada and Europe, that means that there are cultures, with an S, plural. We're not exactly the same. And also, as Julien mentioned in the beginning of this conversation, the legal framework is different. So you have to know that the market will be different in Europe and in Canada. And it's actually the beginning of BCF. And we are from both countries. I work from Paris. Paul and Julien, they work from Montreal. We know each other perfectly. We work as a team. And why are we like that? It's because we know that it will serve the client in the best way possible because of these two worlds, these two cultures, for these kind of collaborations. And for me, that's it.
Wonderful. No, thank you. And I think you just, you've highlighted, what a thread that you all have shared through this, that it's this real sort of building of trust, right? And understanding, sort of from, business strategic sides, sort of, cultural sides, whether that's business practice and sort of just general best practices. And so increasingly, as this happens, we may also start to see sort of the migration of Canadian innovators also sort of more so in the European space as well, sort of that real bilateral approaches as we see that. Sort of fleshing out a little bit of what you said, Marion. Julien, I'm going to turn to you sort of as we look to kind of close out before a Q&A here, is as quantum technology emerges, what are the biggest risks, and or potential, sort of blind spots that organizations should be mindful of?
Thanks, Jen. I guess a fantastic question to wrap up the discussion. But I'll start by saying that I'm a dual citizen of Canada and France. And what I've seen throughout my 20 years living here in Canada and working with tech organizations of different size is that I think as a country, as a culture, Canada, we tend to be a bit too nice and don't realize how aggressive and tough the world is outside Canada. And this is particularly true when it comes to IP. I've worked in Canadian multinationals, and I've seen pieces of valuable IP founded by the Canadian government, built and generated by Canadian citizens, being literally given away to foreign multinationals. And this trend is well documented. There are many papers on the topic. And I think now with the rise of AI and quantum, two technological area where, as a country, Canada, we do have an edge and think the bright talent to play the game, but we need to look at the world for what it is and don't do science for science, but do science to create economic impact, to create wealth for the country. And to do that, we need to step up our game when it comes to shaping up our IP and capturing and managing our IP strategy. And one challenge we faced, I think this is true for Paul also, and Marion to some extent, both in AI and quantum, you'll be dealing a lot with scientists, and they have a natural tendency to be triggered by science for science. We're talking about science to build economical wealth, and to do that, you need to really tie your IP strategy from day one into what you're doing, how you're going to spend your R&D money, and how you're going to shape up your collaboration and your go-to-market strategy. I think to me that's one big blind spot where I think as a country, as an ecosystem, we should be stepping up our game. Be mindful also when it comes to patent in quantum. The US, as Mario mentioned, US and China are really leading the way, and the big players are building a very sizable patent portfolio. So make sure you have this on your radar, and that you also position your R&D and your corporate strategy with the patent and IP landscape in mind, to avoid becoming too dependent from those big players. Are you going to scale up? That's one thing. And the last, I'll stick to only three topics if I want to stay within the allowed time slot. The third one is not per se IP, but export control, because quantum technology can trigger dual use export control, and some technology can fall under critical infrastructure regulation. This is true for if you move technology out of Europe to Canada, or from Canada to Europe or elsewhere, you really need to be mindful of export control laws and to have the proper governance and process in place within your organization for the technology itself, the hardware, the software, and the data. And usually the reason why it's kind of close to IP is that it's a governance process, and it's a matter of having the good practice in place to catch information at the right time and make educated decision before it's too late.
Wonderful. Thank you for that. Yeah, we've covered quite a breadth of stuff. We seem to have a shy, captivated but shy audience, when it comes sort of to the Q&A side. So as we sort of tee up and encourage folks to put any sort of questions before we wrap up into the chat. I just wanted to also kind of ask you all, well, a couple of things. I think an observation, we always, there's a phrase that says the world needs more Canada, right? And so a little bit to what you've talked about in terms of, our forwardness, our openness, sometimes, maybe not necessarily always sort of, protecting things in the way that it is, but from a philosophical standpoint, more increasingly, quantum is a team sport, right? And so I think, sort of having that Canadian player on the team is one you want to have. As you guys are sort of sitting there in your respective seats, what's a key sort of, message or takeaway, that you want to leave sort of with this audience today? Marion, I'll start with you.
I would say, okay, the world is more Canada, and that's true in Europe. Just be interested in Europe. I know the US is close to you, but nowadays, Europe is a fun place to be. And as we've already mentioned, there are great collaborations, and hopefully there will be more and more. So please think about Europe.
Paul?
I think is to not see like quantum as its own separate thing. I think as an organization, I think it'll make its way quicker into the stack than we expect. And I think that much like the line between software and AI is completely blurred as it's increasingly so. And I think that same line will blur between what is, AI versus quantum versus software. I think there's a lot of value to be unlocked. So to not really see it as this distant sci-fi thing that's going to be at some point there, I think it'll come hopefully faster than we think.
Julien?
In coming back to the philosophical question of who we are as a country and value alignment, I think given the current state of the world, there are opportunity for stronger collaboration between Canada and Europe. And I think quantum is a prime example because both jurisdictions have a great scientific expertise. And now it's really a matter of being bold and not miss the opportunity of building owning a valuable piece of this critical technology for the next decades to come.
Wonderful. We often do get questions sort of that come in post, so definitely sort of, thank you in advance, for any sort of, responses and things that we may sort of solicit, sort of from you to sort of share, sort of post webinar as well. In the interest sort of time and knowing also sort of our European friends, it's hitting into their dinner hour. Before I hand it off to Zane, I really want to say a huge merci à vous for carving out time, to look at this sort of very evolving and emerging sort of area that is, vital, for our collective ecosystems, for our world, and helping to demystify some of this. I think there's a lot of sort of, misunderstandings, misconceptions, for example, partly because it is so unknown and so rapidly evolving. So helping to break things down, in today's conversation, and really, I think that the key takeaway I take is, doesn't matter sort of where you start, but start, understand kind of, where sort of you're sitting and where you want to go. And that's going to evolve. It's not a static thing. But start and sort of, have those conversations, and be part of sort of conversations like this. So, Zane, I'll hand it off to you, but thank you again. And this is the start of what is the first sort of a sort of quantum meets, XXX sort of areas, dialogue, I think, increasingly so. So thank you all again. Zane, I'll hand it off to you.
Thanks, Jen. Thank you all once again for joining the webinar today, hosted by Digital and our wonderful Director of IP and Partnerships, Jen. All those attending today will receive a follow-up email in the next couple of days with any resources discussed throughout the session, as well as the webinar recording. And that's it from us at Digital. We'll see you at our next